Alright, geometry. So, with standard 12 again, using special right triangles, out of the 8 here, we have worked on all of the ones that work with the 45, 45, 90 triangles. So, 3 or so of them. Okay, and today on in class 51, we are going to continue to work on standard 12, this time working on the 30, 60, 90 triangles. So, let me pull this apart here. Okay, so special right triangles. So in a triangle that is, I'm going to show this. So half of an equilateral. So if I were to cut this in half, making it a right triangle here, okay? So if it's half of an equilateral triangle, what do we have now? Okay, so it was an equilateral, so all 60 degrees. So if we then cut that in half, making it a right triangle, 2 right triangles, okay? That means I now have 30 degrees here, 60 degrees here. So this is the half of the triangle that was removed, okay? So if the 10 is one side on an equilateral triangle, that means it would be 10 all the way around, right? So when I cut this in half here, what did that make this part? Good, it would just make it 5, right? Because I cut it in half. So we can now find our missing side here by using the Pythagorean theorem, right? So we can call this 5 squared plus b squared. A squared plus b squared equals c squared, right? Okay, so 25 is 5 squared. So if I subtract 25 from this 10 squared, which is 100, I get b squared equals 75. Okay, and when I do the square root of b squared, remember your factor tree says 3 and 25. Which gives me 5 and 5, okay? So how can I write square root of 75 in simplest radical form? Would be 5 square root of 3. Okay, so this pattern would be consistent if we did more examples like this. Okay, so given what we know, using x, as we did earlier in our 45, 45, 90, right? It was x, and x squared root of 2. Okay, first of all, let's get this guy filled in. We then have a 30, 60, 90 triangle. Okay, then the sides will always follow the pattern. Okay, so what side? I'm going to call that x because it's the smallest side across from the 30-degree angle. Okay, what would you say the hypotenuse is then compared to that? I could call it 2x, right? 10 is 5 times 2. And then what would you say is the side opposite the 60 degree? You would use x square root of 3. Okay. So in the same order, I'm going to write the pattern here. So the sides opposite these angles would be x square root of 3, and 2x. Okay. So the side opposite the 30 degree would be your x. Opposite the 60 degree would be your x square root of 3. And opposite the 90 degree, or your hypotenuse, would be 2x. Okay, so again, if my 30 degree is here, my side opposite 30 is x. Okay, my hypotenuse is 2x. And the side opposite the 60 is my x square root of 3. Okay, so again, we have some problems. Looks like 6 problems to practice some simplifying radicals and solving with radicals. So what would 6 square root of 3 times square root of 3 be? Well, we know square root of 3 times square root of 3 is 3. So 6 times 3 would be 18. Okay. 5 is the only number outside the radical. Square root of 15 times 3 is 45. So factor tree, I get 3 times 15 and 3 times 5. Okay, so my pair is a pair of 3, so I pull that outside and I will multiply it. Remember, this is all multiplication. So I'm left with 15 square root of the 5 that was left underneath. Okay, and again, if you feel like you're good with these, finish them out. Okay, then hit play just to check. You can fast forward through the parts where I work. Okay, divide by square root of 3 to solve. So x equals 7 because my square roots of 3 would cancel. Okay, if I divide by square root of 3 here, canceling here, giving me x equals, to get rid of the square root, the 3 isn't the problem, the square root is. I can multiply it by square root of 3, and that will make it just 3, right? But I can only do that as long as I multiply top and bottom, so as to not be changing what the problem is saying, right? We don't want to change what it is, just how it looks. Okay, so 12 square root of 3, I think I wrote a 5 there, that's a 3. Divided by 3, well, 12 and 3 can divide to be 4, and then square root of 3 stays. Okay, next one. If I were to divide by square root of 3, okay, I get x equals, and multiply top and bottom by square root of 3. So I get 11 square root of 3 divided by, what do we know square root of something times itself is? Itself without the radical, right? Because that'd be square root of 9, which is just 3. Okay, and then on this last one, if I divide by square root of 3, nothing, it cancels on my right side. But since 6 and 3 are both under the radical, I can divide those to get them to be 2. Okay, so these will be a little bit more thought-provoking than the last unit because we have to determine what side's what, okay, and then use that to find the other side. So our legs aren't just going to be the same either, right? So I'm going to first say, okay, if that's my 30-degree angle, then that's like my x, and then my hypotenuse is 2x, and then I've got x squared root of 3 from the other side, okay? So again, my x's are labeled following this pattern, okay, and I can use that. It's just after I find them, then I have to say what's a equal and what's b equal, okay? So based on being given the hypotenuse, that tells me that my side that's 2x long is actually 6. Okay, we can solve that for x, right? So we know x is 3, so that this is the side that's x, and this is the side that I take the x times the square root of 3. See how that works? So I can say a is 3 square root of 3, and b is just 3. Okay, so I'll now label my sides x, x squared root of 3, and 2x. Okay, so this time I know side x is 5, so here I can plug 5 in, so 5 squared root of 3. Here I can plug 5 in, 5 times 2 is 10. So I can say x is 10, and y is 5 squared root of 3. Okay. Next one, get my labels in here. So opposite of 30 is x, x squared root of 3, and 2x. Okay, so this is the side I know. So what makes x squared root of 3 equals 6 squared root of 3? And again, they both have square roots of 3, so really it tells me x is 6. Okay, which means 6 goes here, 6 times 2, so 12 goes there. So my x is 12, my y is 6. Spell it out for me. Put what the variables from the problem equal. Don't just leave it up here. Okay, numbers all over the place from doing a little bit of calculations and stuff. Spell it out for me. Okay, so here's my 60 degree. So that means this would be my x opposite the 30, my x squared root of 3, and my 2x. Okay, so the side given to me is my hypotenuse, so I need to find what makes 2x equal 3. So if I divide, okay, 3 halves. So my side with x here is 3 halves. Here, my x times the square root of 3. Okay, so going back to the variables in the problem, I've got to say x is equal to 3 square root of 3 over 2, and y equals 3 over 2. Okay, flip the page over. We don't have quite as, oh yeah, we do have quite as many as yesterday. We have like 25 of them. Okay. So again, though, at any point, you guys, please pause it, do them on your own, and then you feel free to go back and check it. Okay, so next one, labeling each side. The 30 degree, so this would be my x square root of 3, and 2x. Okay, so if x square root of 3 is here with 9 square root of 3, again, they both have the square root of 3, so that's telling me x is 9. So this side is where my x is, so that's 9. 9 times 2 is my 18. So x is 18, y is 9. Okay, next one. So 30 is here, so that's my x square root of 3, and 2x. This is going to be a pretty easy one since I know what x is. X times 2, or 6 times 2 is 12, and x times the square root of 3. So x is 12, y is 6 square root of 3. So as you see, some are going to have a little more work than others. Okay, 30. If I'm going too fast, remember you're watching a video, so you can pause it at any point. Okay, so opposite 60 is x squared of 3. So x squared of 3 equals 2 square root of 3. Again, they both have square roots of 3, so that tells me x equals 2. So my 2 would be down here. 2 times 2 is 4, giving me x is 4 and y is 2. Okay, this one, I know I've got 2x. X is here, x squared root of 3. That's going to be the key thing, is making sure you label your x and x squared root of 3 right. I have no doubt everybody will get the 2x on the hypotenuse labeled correctly. But again, if 2x equals 16, what do we know x equals then? 8. So that's my y here, and then 8 square root of 3. So the x, the variable in the problem, x is that leg, is 8 square root of 3, and the y down here, the shorter leg, is 8. Okay, so what makes 2x equal 9? Well, 9 over 2. So that means y is 9 over 2. And x here is 9 over 2 times the square root of 3. So x I can write as 9 square root of 3 over 2. And y is 9 over 2. And could you put 4.5 square root of 3 in here? 4.5, sure. As long as it doesn't, as long as you're not rounding. Decimal terminates. Okay, so here my x is 5 over 2. So 5 halves times 2 gives me 5 here. X times the square root of 3. So here my x is 5, because that's my hypotenuse. Okay, and the other leg is 5 square root of 3 over 2. Okay, flip the page and keep on going. If you think you got it, go for it. Okay, this time I know 5 square root of 3 is x. Okay, so to get x squared root of 3, I need to take x, which is 5 square root of 3, times the square root of 3. Because my x is just the 5 square root of 3, which really means it's 5 times 3, or 15. Okay, here I need to take 2 times x. Well, my x was given as 5 square root of 3 over 5 times the square root of 3. So here my v is 15, and my u is 10 square root of 3. My x times 2. Okay, next one. Again, I was given the x value. Okay, so take x times the square root of 3. Okay, so here my x is 5 square root of 2, so I'm going to take 5 square root of 2 times the square root of 3. Here I'm going to take 2 times 5 square root of 2 is my x. Okay, so v is 5 square root of 6. Again, if I could simplify the square root of 6, I would, but I can't. And my u is 10 square root of 2. Okay. Here, I I've got the x squared of 3 side is given as 4 squared of 6. So solve for x. And because these are both under the square root, I can divide to go ahead and get 4 squared of 2 for my x. Okay, so my x is the side that's actually labeled y. And here I'm going to take 2 times x, which is 4 squared of 2. 4 squared of 2. Okay, so my x is 2 times 4 is 8 squared of 2. And my y is the 4 squared of 2. Next one, I'm actually given the hypotenuse, which is my 2x side. Okay, so what makes 2x equal 8 squared of 3? Well, if I solve that, I get x has to be 4 squared of 3. So this side would be 4 squared of 3. And this side would be 4 squared of 3 times the square root of 3. Okay, so n is just 4 squared of 3. Can't do anything there. M would be 12 because these guys give me just 3. Okay, so here's my 30 degrees. So I've got x squared of 3, and 2x. So I'm given the side with x squared of 3 is 9. Okay, so divide by square root of 3. And a reminder, I can't leave square roots in the denominator, so I'm going to multiply top and bottom, which gives me 9 square root of 3 over 3, and 9 can divide by 3 to give me 3. So my x side is just 3 square root of 3. 3 square root of 3 times 2 will give me that side. So my y this time is 3 square root of 3. Okay, and my x is actually 6 square root of 3. Okay, so here I've got x squared of 3 and 2x. So 2x is 8 squared of 6. So dividing by 2 tells me that x is 4 squared of 6. So that would be x side is this side. Okay, and then I've got 4 squared of 6 times the square root of 3. Right, so that would give me 4 square root of 18. 6 times 3 is 18. They're both under the radical. And then do your simplifying. 3 can come out of there. Multiply by the 4. So 12 square root of 2. Okay, so x is my 12 square root of 2. Y is the 4 square root of 6 that I found to start with. Okay, I think we got one more page here. Get anything in there, we can do it. Okay, and again, nothing says if you've got this, go for it. Okay, if you want, do the whole sheet, and what I'll do is after I work through all 9 of these, I'll zoom it out. So if you want to fast forward, if you're going to pause it now to work through these last 9 problems, you can fast forward it then when you're done to the end to look at each of the answers, and I'll circle the answers to help them stick out a little bit. Okay, so that way you can fast forward and you can keep on going, and you can have a good way to check to make sure you're good. Okay, so x squared of 3 and 2x. So if 2x equals 20, then I know x equals 10, right? So that means that side's 10, and I've got 10 squared root of 3 here. So the variables in the problem say x is my 10 squared root of 3, and y is my 10. Because remember, my x's just come from the original, this original statement, right? x squared root of 3 and 2x. Okay, that's where mine's coming from. Okay. So if that's x, I can take 2 times 3 squared root of 3. If that's x, I can take 3 squared root of 3 times the square root of 3. Okay, so to get m, I get 6 squared root of 3. And to get n, I get 9. So x squared root of 3, and 2x. So x squared root of 3 has to equal 3. Dividing by square root of 3, it means I gotta simplify by multiplying top and bottom, giving me 3 square root of 3 over 3. That cancels, giving me my x, this x, is just the square root of 3. X is square root of 3 times the square root of 3, which gives me my 3 that was given, and then here it's 2 times the square root of 3. So the x in the problem says I get 2 square root of 3, this is the x in the problem, and the y says it's just square root of 3. Okay, x squared root of 3, I like this one. X squared root of 3 has to equal 7 square root of 3, so since they both have square roots of 3, I know x is 7, so that makes that side 7, times 2 makes that side 14. So a is 14, b is 7. Okay, so I know 2x is 4 square root of 3. Dividing by 2 tells me x is 2 square root of 3. So I've got my x is 2 square root of 3. My x here is 2 square root of 3, but I got to multiply by another square root of 3. So b is 2 square root of 3. And a is 6, because square root of 3 times square root of 3 is just 3. Okay, so I've got x square root of 3, and 2x. So in this case, I know x is 7, which makes the problem even easier. So 7 times 2, here it's 7 times square root of 3. So x is 14, y is just 7 square root of 3. Okay. So x squared root of 3, and 2x. So again, I know 2x is 6 square root of 2. So divide by 2. And my x is 3 square root of 2. So my x is what I have in here. So this side's 3 square root of 2. This side is 3 square root of 2 times the square root of 3. So n is 3 square root of 2. And m is 3 square root of 6. Because I can multiply 2 and 3 since they're both under the radicals. Okay, get my labels in, my initial labels. So I know 2x is 5 squared is 6, divide by 2. I can't simplify that, so I'm going to leave it. So my side with x is right here. So x is 5 squared is 6 over 2. Here I get 5 square root of 2 over 2. Sorry, 5 squared is 6 over 2. Multiplied by square root of 3. Okay. So my x is the problem's y, so y is 5 squared is 6 over 2. X, okay, square root of 6 times square root of 3 is square root of 18. Do your factor tree, so 2 and 9, and 3 and 3. So there's my pair of 3's that can come out of there. If I pull a 3 out of there, I have a 5 out there already. So I have 15 square root of 2, because that 2 didn't have a pair, over 2. There are my answers for the x and y variables in the problem with 2 different wavelengths. Finally, the last one. Now they did lots of examples on these. That's alright though, we got it. Okay, so we've got x, square root of 3, and 2x. So 2x is 3. So when I divide by 2, I get x is 3 over 2. Here, I get x times the square root of 3. So u is 3 square root of 3 over 2. Nothing can simplify. And b is just 3 over 2. There you go. Okay, different work. So based on it with being given one of the legs, okay, given one of the legs, either one of the legs or the hypotenuse, can you find the other missing sides on a 30, 60, 90 special right triangle? So there are those answers so that you could hopefully fast forward to get to this point, pause it, and check all of your answers. And if you're stuck, you might want to rewind it if you can't tell by my work how to fix what you did wrong. Otherwise, you should now be able to go ahead and complete homework 51.